Hey everybody, we are going to be doing lesson 4-4. Today in class we did lesson 4-3, and in that lesson we were able to see how triangles are congruent to one another by showing that all of their angles were congruent and that all of their sides were congruent. Well, today we're going to start learning some shortcuts for showing that triangles are congruent to one another, and we're going to do so without having to prove all 6 pieces of the puzzle. In other words, 3 angles, 3 sides. Today we're going to do shortcuts that use about half that much information, and it has the potential to be a long video, but I am going to try to consolidate and move quickly. So you just remember that you can pause the video to review anything that you need to. You can go backwards and look at it again, and I'll move as quickly as possible. All right, so the first thing that we're going to look at today is the fact that we can show 2 triangles congruent by only knowing that their sides are congruent. So let's start looking at that. I am on page 242. Again, this is lesson 4-4, and I'm just going to start in the middle of the page. We're going to start with postulate 4-4-1, that's side, side, side congruence. And as you'll see, it's abbreviated SSS, side, side, side. All right, let's look at the top 2 triangles. If we know that 3 sides of one triangle are congruent to 3 sides of another triangle, then we know that those 2 triangles are congruent. So look at this. We see, I'm trying to make sure that you can see all of that. Let me adjust the camera just a tiny bit. Okay, so we can see that AB is congruent to DF because both of them are 4. We can see that BC is congruent to DE, both are 6, and the AC is congruent to EF, both of them are 7. We have shown that all 3 sides of this triangle are congruent to 3 sides of this triangle, and therefore we have proven that these 2 triangles are congruent based on the side, side, side postulate. So that's all that we need. We don't actually have to show all 3 sides and all 3 sets of angles in each triangle. We can prove that they're congruent by simply showing that all the sides of one triangle are congruent to all the sides of another triangle. The reason for that is something called triangle rigidity, and that says that if we know all the sides of a triangle, it can only take on one shape. So therefore, if another triangle has all those same side lengths, it can only take on the identical shape, and therefore the 2 triangles are the same size and shape, making them congruent. So that's what allows us to say that triangles are congruent by side, side, side. All right, let's look at the diagram right here. And this is example 1 right below our postulate. Use side, side, side to explain that triangle PQR is congruent to PSR. Now, if you're looking at your book, you'll see that they give us the map. They actually say triangle PQR is congruent to triangle PSR. Remember, that map is our key to knowing which angles go together and which sides go together, which we practiced in class with lesson 4-3 today over and over. All right, so since we know that it's given that PQ is congruent to PS right here. Now, they actually gave us that in the diagram, but it was also given in that map or that key. We also have a given that QR is congruent to SR. The reason that's given is because it's part of the diagram. So how could we prove the top triangle congruent to the bottom triangle based on side, side, side when we're only given 2 sides that are congruent? Do you remember that reflexive property that we talked about earlier in the year and that we talked about in class several times today? I said it would be essential to you in using it over and over to prove triangles congruent. It's stating that one part of a triangle is, or any other shape that we might be working with, is congruent to itself. So our third piece of the puzzle here is that PR, part of the top triangle, is congruent to PR as part of the bottom triangle because it's a shared side. It's congruent to itself. So we would say PQ is congruent to PS, QR is congruent to SR, and PR is congruent to itself, to PR, by the reflexive property, and now we have 3 sides. 3 sides of the top triangle that are congruent to 3 sides of the bottom triangle. Therefore, we have proven that this triangle is congruent to this triangle by side, side, side. Remember in your homework, when you write that the two triangles are congruent, you must write them in the correct order. And actually, I'm not sure I ever said that in class today. I said use the map to find the things that are congruent, but the other side of that, the flip side, is that when you state that the two triangles are congruent, you must state them in the correct order. You must rewrite that map or that key that presents them in an accurate order. So in other words, if I said triangle PQR is congruent to the bottom triangle, I must name the bottom triangle in the same order. So PSR, because I'm moving from P to Q, I've got to move from P to S because those are the two congruent parts. If I'm moving from Q to R, I've got to move from S to R because those are the two congruent parts. So make sure, that's imperative, that you're naming those triangles in the correct order. If I name this triangle RQP, how am I going to name the bottom triangle? I've got to follow that same pattern, RSP. Or if I name the top one RPQ, I've got to name the bottom one RPS. So it's just the reverse of what we did with reading the map or the key. Now we've got to write the map of the key based on the information that we're given. All right, let's keep moving. Let's move and look at this one, and I need to see if that's still in your diagram. I mean, in your window. Not quite, but now it is. Okay, so use side, side, side to explain why triangle ABC is congruent to triangle CDA. This is check it out, number 1. How can we say that these are congruent? Do we have enough sides in this triangle, the upper right triangle, to compare it to the sides in the lower left triangle? Well, we know that 1 is congruent, right here, 1 tick mark. AB is congruent to DC, and then we know that BC is congruent to AD. Where's that third side? It's the shared side that you need to be looking for. It's this shared side between the two triangles, and it's AC. AC is reflexive. It's congruent to itself. AC is congruent to AC. So now we know all 3 sides of each triangle, and we see that there are 3 sets of congruencies. Therefore, we can say that this triangle, ABC, is congruent to this triangle, CDA. Hold on now, I'm not sure I named that right. ABC, yeah, I did, CDA. Again, look to see that I'm making sure that I've named them in the same pattern or same order. And I can say it based on side, 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 reflexive, congruent to itself. Okay, now let's look at this. That means I'm going to need to move this one more time. And we are going to be looking at this triangle, triangle ABC. What I want you to see in it is that we have an angle filled in. This is angle ABC and triangle ABC, and we call this angle that I've shaded an included angle. This angle, I'm going to turn this just a little bit more. This angle sits between side AB and side BC. That's why it's called an included angle. The fact that it's included between the 2 sides helps us move on to our next postulate, which says that we can use 2 sides and an included angle to show 2 triangles congruent. So let's move to the other side of the board, and I'm going to move my camera. Now, one thing I want to remind you is the included angle must come, absolutely must come between the 2 sides that we're working with. So we are now moving from the side, side, side postulate to the side, angle, side postulate. And the angle here for you is probably less than perfect. So let me see if I can adjust that a little bit. Maybe that'll help. So we're now going to look at the side, angle, side postulate. Notice that those cannot go in just any order. You must move from a side to an adjacent angle. That means an angle that's right beside it. And then to another side. I can't jump from here, side, angle, side, because there's a side in between them. And there's an angle in between them. I must go in order of things right next to each other. So, side, angle, side, or side, angle, side. Or I could do this side, side, angle, side, or side, angle, side. But they must be right next to each other, must be in order. Okay, so let's see. We are now looking at the top of page 243, and I'm going to read you the postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then we can prove those two triangles congruent. So again, we're able to prove the two triangles congruent, knowing only three parts of the puzzle in each triangle: two sides and an included angle. So, looking at this example right here, we see that AB is congruent to EF. We see that the angle next to side AB, angle A, is congruent to angle E, which was the angle next to side EF. And we see that the next side, AC, is congruent to DE. So we have side, and it is an included angle. Super important. All right, let's look at example 2 below it. This is the Statue of Liberty example, and you'll see that I have redrawn the diagram that comes from the supports in the Statue of Liberty. And it says the figure shows part of the support structure of the Statue of Liberty. Use side, angle, side to explain why triangle, I'm going to write this out here, triangle KPN is congruent to triangle LPN. Let's look at KPN, let's look at LPM. Notice that they were named in the way that the map shows that they're congruent. I went from, let's see, KPN, single tick mark, double tick mark, and LPM, single tick mark, then double tick mark, okay? All right, now let's look at how we could prove these congruent based on side, angle, side. Well, I see that I have a side in this triangle congruent to a side in this triangle. I see that I have another side in this triangle congruent to another side in that triangle. But where's that angle? It has to be the included angle between the two sides for it to be side, angle, side. So where is that angle, and how do I know that it's congruent if it wasn't given? Y'all, look at this diagram and see if you can evaluate that. What makes those two included angles congruent? You know this. It's one of the few things that you can deduct or deduce just from the picture or the diagram. It's the fact that these are vertical angles, therefore they are congruent. So we do in fact have side, angle, side. We have a side, an angle, and a side congruent to a side, an angle, and a side in the second triangle. And we write them as congruent in our map or our key. All right, let's look at this one. Same thing. How do we use side, angle, side to show that these two triangles, the top and the bottom, are congruent? How do we show that triangle ABC is congruent to DBC? Well, we have a side. AB is congruent to DB. We have an angle that's DBC is congruent to ABC. And we need another side. Side, angle, side. Where's that side going to be? It's got to be the side that comes after that included angle. So side, angle, it has to be this side. How do we know that that's a congruent side? That's one of the other things that we can deduce just from looking at the diagram. That BC is a shared side between both triangles. That means they both use it. Therefore, it is congruent to itself. And remember, we call that the reflexive property. So triangle ABC is congruent to DBC based on side, angle, side, or side, both sides, top and bottom, angle, congruent angles, and the middle shared side. All right, let's see. Let me flip the page and you go ahead and do the same thing to page 244, and I'm gonna stop this video and start a second one and make sure that you watch both.